Hello everyone, and thank you, Raphael and David, for inviting me to participate in this symposium. My name is Aylin Sertkaya, and I'm with Eastern Research Group. As the title of my talk indicates, I'm going to be talking about insights and lessons I've gained having conducted expert elicitations for dozens of research projects commissioned by federal agencies. Now let's begin by talking about what an expert elicitation is. It is a structured method of systematically consulting experts on uncertain issues, and the quality of knowledge in terms of its transparency and reproducibility improves through the application of a systematic approach. Expert elicitation can be used to quantify ranges for poorly known parameters, but can also be used to address qualitative issues such as definitions, assumptions, and causal models. The application areas for expert elicitations are quite diverse and range from nuclear engineering, forecasting, environmental risk assessments to health technology assessments for biopharmaceuticals. The use of formal expert elicitation dates back to the 1950s. Since the early 1970s, decision analysts, modelers, economists, and others in private and public sectors have used formal expert elicitations to obtain expert judgments to gather data not accurately known or available, to put together the structure of a model, to develop causal relationships in complex economic or social phenomena, and also to prioritize objectives. So there are many technical, administrative, political, and procedural factors that influence the decision to conduct an expert elicitation. And for a given project, one needs to consider several factors when deciding whether to conduct an expert elicitation. For instance, if data of suitable quality are unavailable or unobtainable, if there is conflicting evidence or conflicting models, if expertise is available, that the body of knowledge exists, and if there are resources available, it might be desirable to conduct an expert elicitation. On the other hand, if empirical data exists with a high degree of consensus, and if there is insufficient expertise, and there are other acceptable methods for obtaining the information that are less intensive and less expensive, then an expert elicitation may not be so desirable. So what does a typical expert elicitation process look like? There are a variety of expert elicitation protocols, but there is no universally accepted method. The method adopted often needs to be customized to the needs of the study, and that usually is an iterative process. The depicted 9 steps on this slide describe good practices, but the process of expert elicitation should not be approached as a routine procedure amenable to cookbook solutions. Each elicitation should be considered a special case and be dealt with carefully on its own terms. First of all, one needs to clearly identify the information needed from experts. And then comes determining the preferred elicitation scope and format, taking into account the information needed, the intended use of the information, availability of expertise, and resources. One needs to think about how many experts to consult. Will you be compensating these experts? Will you be holding group or individual elicitations face-to-face? Will you be doing face-to-face interviews or using self-administered questionnaires for the expert elicitation? And will there be a need to aggregate the results of the elicitation? Here are 5 studies quickly identified that have used expert elicitation in tobacco control research. As can be observed from the table, studies vary significantly in the number of experts used, from 8 to 34. The adopted protocol for the expert elicitation, the mode of administration they used, as well as the aggregation method they utilized. I just want to draw your attention to 2 studies on this table. The first one is the first row, and that is the only qualitative expert elicitation study among the 5 studies identified. Now, rather than developing quantitative estimates, the study authors in this study used expert elicitation to develop a conceptual framework to describe and categorize the different strategies tobacco industry uses to undermine tobacco control programs. They also used behavioral aggregation by bringing the experts together after the first part of the elicitation to reach a consensus on this conceptual framework. Another study that I would like to highlight is the last row, which is the most recent one conducted by Levy et al., a study that I had the privilege to participate in. In that study, the expert elicitation was designed to estimate transitions from cigarette use to other tobacco products under a federal menthol cigarettes and cigars ban. But unlike the first one, this one was a quantitative expert elicitation aimed at getting transition probability estimates, primarily for use in tobacco simulation modeling. The study included 11 experts and used self-administered questionnaires using the Delphi method with 2 rounds, and expert responses were aggregated using equal weights, using mathematical aggregation. Expert elicitation is also used in other areas. Here are some examples of expert elicitation used at FDA's food safety program, EPA's criteria air pollutant program, and also at IPCC to address specific components of the climate change issue. Now let's get into the lessons I've learned. Who takes part in an elicitation can greatly affect its outcome and its acceptability in the wider community. So which experts to consult requires careful consideration. Generalists have substantial knowledge in a relevant discipline and a solid understanding of the context of the problem, and these types of experts are useful to include in elicitations involving context or model structure uncertainty, especially those where the problem is multidisciplinary in nature. And there are subject matter experts. They are authorities in a given field of expertise, and they're useful to include in those elicitations that require subject-specific information, such as model parameters. And then there are normative experts. These have knowledge and practical experience that can support the elicitation itself. And these are individuals with specialization in decision analysis, statistics, economics, and psychology. It is important to have a well-balanced panel when there is high degree of value diversity, high stakes, or when the results need to be accepted by a wide peer community. And it is preferable to use a formal selection procedure to ensure opposing views are presented on the panel. Common approaches to identifying experts include literature reviews, citation analysis, use of the snowball approach, where you identify a few experts first and then allow those experts recommend other experts. But in putting that panel together, one needs to recognize that understanding the body of available information is important, but not sufficient to serve as an expert on an expert elicitation panel. Intuition and ability to integrate that information beyond the reported data are also very critical. There is no absolute guideline on which to base the number of experts to solicit for an expert panel, but we can get some idea by looking at the number of experts used in past expert elicitations. And here are two studies, one from 2015 and another from 2018, that did just that. So based on these, the optimum number of experts for a panel approximately ranges from 6 to as high as 22 experts. Now, one needs to be cognizant of the fact that there could be diminishing marginal returns for including additional experts in an expert elicitation. And the general feeling among practitioners is that beyond 12 experts, the benefit of including additional experts drops off sharply. Doesn't mean you can't, but you're going to hit diminishing returns after 12 experts. The wording of questions and use of qualitative terms in an expert elicitation need very careful consideration. Quantitative probability associated with a qualitative term varies significantly from expert to expert. And you can see this from the figure, which shows the results obtained when members of the executive committee of the EPA's Science Advisory Board were asked to assign numerical probabilities to uncertainty words that had been proposed for use with EPA cancer guidelines. And you can see the range for the term likely, something between likely and not likely, how it maps to quantitative probability of estimates across different experts in this figure. This is also another reason pre-testing of questions is highly recommended, because slight phrasing of the same question has been shown to lead to differences in responses. Now, experts use various heuristics when judging uncertain information, and this may result in biases. All of us use heuristics in making judgments, not just experts. But availability bias arises if the expert is affected by the ease of recall or the memory of recent experience. Anchoring and adjustment refers to the procedure of experts to first select a starting point as a first approximation and then to adjust this value to reflect supplementary information. Results end up being biased toward the anchor. Representativeness bias refers to inappropriate generalization of specific knowledge. And overconfidence leads to estimates that have narrow spread when in fact the true spread is larger. And this may be reduced by asking about high and low values before asking about the central tendency. Hindsight bias refers to the tendency of people to exaggerate the predictability of reported outcomes because they fail to think about how things could have turned out differently. And motivational bias arises when the responses are influenced by factors such as moral or professional responsibility, legal liability, or peer credibility. Therefore, it is important to mitigate or minimize biases resulting from the use of heuristics in making judgments. It is good practice to familiarize the expert with the elicitation process, use familiar measurements, and ask questions within the area of expertise of the expert panel, possibly decompose the expert elicitation into smaller, distinct parts, or perform combinatorial exercises. As we discussed previously, being specific with the wording and possibly using graphical representation whenever possible. Not providing the experts with example numbers to anchor to. and asking the expert to discuss estimates and give evidence for and against them. And finally, providing feedback to the experts and allowing the experts to reconsider their responses are helpful for mitigating and minimizing these biases that arise from use of heuristics.
Aylin, it's like 8 minutes, let's say, so the next time.
Okay, three more slides. So to fully engage experts and to minimize attrition, and this is especially relevant for expert elicitations involving large panels, it is important to prepare the experts for the elicitation. One should introduce the scope and purpose of the study, and this may be provided in a briefing book that contains the outline of the nature of the problem, key literature, or a summary of the literature, information about the expert elicitation procedure itself, and also information on heuristics and biases. Now, one may also want to provide training on how to think about probabilities and how to avoid biases. And it's also important to provide post-elicitation feedback, which can be instantaneous while the expert is completing the questionnaire, if it's online, or it could be delayed after they've completed and submitted their responses. This allows the expert to reflect on their responses and make any adjustments if needed. Now, in the expert elicitations that we have done, we found out that instead of providing a long briefing book, holding training webinars to familiarize the experts with the scope and format of the elicitation worked better in terms of engaging experts and minimizing attrition. Now, I just want to conclude with some additional insights on expert elicitations. Now, if all experts in a given panel agreed 100%, there would be no need to worry about how to aggregate expert responses. But experts vary in their estimates, and these variations could be quite large, as we have seen in the expert elicitations we've conducted. And researchers typically resort to mathematically aggregating expert responses where each expert's response is equally weighted. However, several recent studies show that performance weighting of expert responses performs better than equal weighting, but only slightly. Performance weighting approach is also known as the Cook model or the classical model, and uses calibration questions throughout an elicitation to determine what weight to attach to each expert's input. Now, calibration questions are questions related to the panel's expertise, whose answers are unknown to the experts, but known to the facilitator. And based on the precision of responses of experts to the calibration questions, each expert gets assigned a performance weight, which is then used in the mathematical aggregation. Now, it is quite difficult to come up with good calibration questions, and that's an effort difficult to undertake in and of itself, in addition to the expert elicitation administration. The jury is still out on the different elicitation methods, what is preferable, whether Delphi versus the nominal group technique or versus decision conferencing. I also want to point out again that expert elicitation is well suited for complex technical problems, unobtainable data, conflicting conceptual models, but it really is not a substitute for rigorous empirical methods. And finally, we talked about the variation in responses. Understanding the source of differences among the experts can actually lead to insights and ultimate consensus, or the revision of the elicitation protocol And this, in and of itself, may be more valuable than any aggregate finding. And with that, I'm happy to take any questions.
Thank you, Aylin. That was great. And why don't we do one question and then we'll leave the rest for the panel. So this is from Doug Luke, which is a great question that we've debated a lot, and it'd be great to hear your thoughts. So I will read it. For expert elicitation studies done by your group, I would like to hear more details on how diversity of expertise is ensured. Specifically, I worry about how the use of traditional academic publication matrix, for example, the H index, will tend to produce experts who are older, whiter, and male.
Yes, that's a great question. And we do try to be cognizant of that, even though we have used the H index and other methods. Ultimately, it's important to take a look at the composition of your panel and whether it's balanced. And that's one of my slides were pointing out to the fact. And one person might have a high H index, but you might opt to exclude them to introduce more diversity to your panel. But again, as with anything with expert elicitation, that's also a subjective determination done by the researchers, and in the studies that we've done in collaboration with the agencies that were sponsoring those studies.
So, well, there's a quick question I think might be hard, a long answer, but maybe at least I want to ask and just see if you have quick reactions. So from Jihi and John, so if the ranges are to vary, maybe the results are not very helpful, right? So what is the usual practice to aggregate the values? Do you use mean, median, or what else? Do people usually like remove outliers, or how do you handle a little bit that it's variability that I guess is expected to expert opinion?
Another excellent question. Well, we've never resorted to removing outliers. The reason that you select the expert to serve in a committee is because they have the relevant and applicable expertise. But in terms of aggregating responses, typically means and medians are used, the linear pool. Sometimes you might want to use a logarithmic pool. And at other times, and this is actually a good practice in terms of reporting expert elicitations, you don't aggregate the responses, you report anonymized responses applicable to each expert. And then possibly if those are going to be used in, for instance, a modeling study, you can introduce some sort of a Monte Carlo simulation that would pull from different experts' responses rather than an aggregated expert response.